So yes, thanks a lot for hosting us this year. We are very, very happy to be here. With me are some member of the team. You can't see them, but basically they are there. And I would like to thank you, the attendees, but also the organizer and the Cake PHP core developers. As Larry said, we would not be there without you. So thanks a lot. I don't know if we can use the chat to give them a little clap emoji. Thanks a lot for your hard work and for having us. So who am I? I'm the Remy Bertot. I'm the co-founder of Passbolt. What is Passbolt? Passbolt is an open source password manager for teams written in Cake PHP. It's hosted on your computer or on someone else's computer, also called the cloud. And basically, it's Linux native. It's also cloud native, so you can find the AMI on AWS and on DigitalOcean. You have full data ownership. Everything is interoperable, and it's 100% open source, even the paid version. So we offer a 360-degree No, I'm joking. Actually, this time it's not like a blue screen. I'm just trolling you. So don't worry. I'm not gonna make an advertisement about Passbolt today. What I want to use this time for is to reflect on our mistakes, what we did wrong, so that you can learn from them. I think like being transparent about our mistakes and the problem we faced will maybe help you to get to some solutions to your problem. Because as the wise man said, if you really understand the problem, you will understand the solution, because the problem is not separate from the solution. So, which brings us to part 3, security. What are our biggest security mistakes that we did in the past? So the first one, because in Passbolt, we always say if there is a problem, especially the development team, it's either the database or the DNS. So I'll start with the DNS. This story started on a Friday evening where we had Diego doing a critical change in our infrastructure alone, the last one in the office. And obviously he made a small mistake and he replaced like an N with an M, and he was staring at his screen with all our services down and not figuring out what it was. And so basically he gave us a call. We came back to the office and we look at the screen and we were like, are you sure about that letter? And basically the whole system was up and running. So like 2 morals to these stories: don't release on Friday. I mean, unless you're feeling confident. And if you are, make sure you have like 2 pairs of eyes looking at the problem, because sometimes the solution is very, very simple, but you will miss it because you're freaking out. So that's the story for this one. Another one that when it comes to security, and especially encryption, a lot of it relies on pseudo-random number generation. So the rationale is when you encrypt a content, at the end it should be you cannot distinguish it from truly random content. So in order to achieve this randomness, you need sources of randomness. So in practice, that means that you need sources of randomness, also called entropy. And depending on the functions that you use, you may not get this. So you have some pretty simple mistakes that you can make, and that we have made, is to use non-cryptographically secure random functions. For example, here, like mad random in JavaScript, or like rand in PHP. And it comes down to reading the manual. So when you're working with a secure system, and you can always start by looking at where are your sources of randomness. So some of it are easy, like for example, you should not use these unsecure functions, but sometimes it's less easy. For example, when you're on a server in a virtual environment and you have services that rely on randomness, then you will need to look into like how is your operating system configured, Is it using like a correct source of randomness? Do you need to introduce some more randomness? And it comes down to investigating this. So randomness everywhere, indeed. Another simple mistake that we did in the past is URL confusion. So as you may know, Passbolt relies on a browser extension, and this browser extension insert on web pages little scripts for the application to work. So when you set up Passbolt, you associate your extension with a trusted domain. And then based on that, we will insert the login page or the main application into the page. So maybe someone can find what is wrong with this particular piece of code. We are using here like a regular expression to find out if we should insert or not the login page on a trusted domain. So I'll give you like maybe 5 minutes in case somebody wants to try to find this one. So what can go wrong when using regular expressions? Many things. So yeah, in our case, basically, we were not escaping the dot. So if you have a trusted domain that is demo.passbolt.com, basically the dot count as an element in a regular expression that means basically match anything. So it would be possible for an attacker, before we fix this flow, to register a malicious site that would be cloud.passbolt.com and basically be able to target some users so that basically the application is inserted in that page. Fortunately, we have several layers of security that prevented this attack to be usable, but basically it was still like a mistake that we did. So what you should do when handling URL is generally, it's better if you use URL parsing libraries, or typically in JavaScript, you will use the URL object so you can manipulate the URL safely. Here, for example, is an example on how you can find a parameter that you're looking for in the URL. But even if you are using parsing library, again, you should read the manual because there might be some edge cases and some things that are not properly handled by these URL parsing libraries. So as Clippy is saying, another thing you should check when handling URL is the redirection. So in your cake.php application, every time you're calling redirect, you should make sure that basically that URL specified here is from a trusted source, or that at least you sanitize it to make sure that it's doing what you want, and that an attacker cannot use that to create some form of attack. So another typical problem with web application is cross-site request forgery. So it's an attack, if you're not familiar with it, where an attacker will craft a form or a link to make a user click in a third-party domain and perform an action in your application, in our case, Passbolt. So by default, cake.php protects you from that. So you will have a little token that is sent in the header, and cake.php will check if this value match the one that is in the cookie. And this way, an attacker cannot read on a third-party domain the value of that cookie. So you're pretty much protected from this type of malicious attacks. However, you can badly design your application like we did and create some state changes on some operations that are not covered by that cross-site request forgery protection, such as GET request. So GET request, for example, in the application, we thought it would be great to have a URL where people could log out, but that means that an attacker could call that URL and log you out from your Passbolt instance. So when you're doing code review, it's one of the things that we look for is checking if the method is correct for the HTTP calls. So another problem we faced last year, mistake we did, again, it came down to not reading the underlying code of the libraries or the manual, is we triggered authentication bypass in Passbolt, due to GWT key confusions. So to give you a little bit of context, GWT is a little token that you send to the server to authenticate, especially, for example, for us on mobile. And this token is verified using some cryptographic operation, such as signature verification. So GWT supports several algorithms. One of them is based on hashMAC. So it's a hash-based operation, where basically it's very common in applications where the code is not open source, where you would have a mobile application which have a shared secret with a backend, and using that shared secret, you'll be able to create a little signature. But in our case, because we want, for example, the web application to be able to authenticate using this method, we use another algorithm that is based on RSA, which is public key cryptography, where basically you don't have this shared secret. You have like a public key that is known by the client. And these two algorithms are very different in the way they function. So, but unfortunately for us, both of these algorithms are supported. And when we were merging our configuration with the one in Cake.php, we ended up with both algorithms being supported. So it was possible for an attacker, for example, to use the RSA public key and use the hashMAC operation and say craft a GWT token with that hashMAC and basically bypass the authentication this way. So fortunately for us, our security researcher found this issue before it was available to everyone. But still, you know, it was as close as we got from an authentication bypass in Passbolt, so it's pretty serious. When it comes to GWT, there's a lot of mistakes you can do, so it's always good to really take the time to understand what you're doing, but also read the implementations. So for example, in our case, it was a collection of issues, like there was a bug in a Firebase GWT, which is a library that is maintained by Google, and there was this configuration merge that basically made that attack possible. And but there are other type of attacks. For example, some libraries support the algorithm known, so you can completely like bypass the authentication by saying like I don't want any check at all. It's less common, but it can still exist on some system. So you may want to check that. So what is wrong with this one? So this one is a Nginx configuration. So again, I'll let you like maybe like some time to think about what can go wrong, what is wrong. I mean, apart from using Emacs, yes, it's the location of the web root that is wrong. And this problem, you as a Cake.php developer, you may know that, you know, this is how you should configure Nginx, but maybe you're handing over the hostings to someone else who doesn't know that. And so the issue again here is more about like knowledge and transfer of knowledge, and making sure that the developers are talking with the people handling the hosting, so that they know what the application is supposed to be doing, how it's supposed to be configured, and taking the time to learn that knowledge. Another attack, which is like less common and mistake that we did repeatedly actually, is not escaping some of the content of our application in the emails. So it's pretty common these days to have front-end libraries that escape the content from your database in your front-end. So for example, if you're using React, it's pretty safe by default, unless you basically specify that, okay, I want to do some unsafe things. But for emails or for like general rendering of variables, in HTML, you won't have that that failsafe. So remember to make sure to escape the content of your emails, even though the problem affected will not be yours, but it will be the email client of the end user. And similarly, you can have this type of problem on file exports. So here, Clippy is proposing to run this little command in Excel, which is probably not a good idea. So this brings us to the third categories of mistakes that we did in the past. So performances. One of the common performance issues, you always have the DNS issues, but you also have like the SQL issues. So I'm going to talk a little bit about the SQL issues. In our case, this relates to an outage that we experienced last December, which lasted a few minutes. And basically, it's a collection of wrong choices over time. So we had initially a column that basically is storing IDs, foreign keys and primary keys. We are using UUIDs for everything in Passbolt, but they were using the wrong collation. So UTF-8 MB4, which basically allows you to store other characters that you would never find in a UUID. So in order to gain some performances, we changed the collation to ASCII general. So it was giving us some additional performance there. But however, there was still on some of these indexes, we were not using them anymore. So we had indexes from the version 1, we had some SQL queries that were using them, and then basically we rewrote that code after some time, and we were not using these indexes anymore. And so when we did that change, the SQL optimizer starting using this old unused index that were not used before, because we changed the collection, and suddenly that index was attractive to the optimizer, and we ended up having some performance issues on some data topology. So we have, for example, very different type of users that use Passbolt. We have people that have like small team, but they have like 20,000 passwords that are shared with everyone, or we have like people that have 200 people and they all have one password each. And so we have like very different data sets. And in our performance test, we are not always testing with every single data set that is possible. So this is one of the things which we are trying to work on now, is basically do performance tests with not just what we think is the normal usage of Passbolt, but also try to find, okay, where are the outliers there in their usage of Passbolt, and how can we include this type of usage in our test to make sure that we identify these performance issues quicker. So there is a talk by Dave about SQL optimization at 4:55. So if, like me, the SQL optimizer is a bit of dark magic, we can all learn from that at that time. So another mistake that we've seen mostly from our customers is sometimes they will face performance issues and they will look at their server log and they will see, okay, basically there's an error saying that a server has reached PM max children, and I should raise that. And then they raise that number not knowing what it is for, and then they end up with even worse performances. So if you're not familiar with PM max children setting, basically this setting is highly dependent on the amount of RAM that you have on your machine. So generally, you will take the total amount of RAM that you have on your machine, remove what is used by the operating system, and divide it by the number of php-fpm processes, and then that will give you an indication on whether you can actually raise that number or not. So again, it comes down to learning and having a look on what this error really means, and like what should be done about them. Another common performance mistake that you will find in Passbolt is that we have reused a single operation and built multiple record operation on top of them. So this was sometimes driven by because these operations are not critical, but sometimes it was because we need to go fast, or we were not confident that we could build this multi-records operation as safely as we have built them when they were atomic. So sometimes, you know, it was just bad design. And so ultimately, when you take this approach, you end up with a slower front end, more HTTP queries, more SQL queries as well, or slower transactions, duplicate validation, or like build rules that you could factorize and that you are not factorizing, and some weird notification logics. For example, if you're doing like a multi-insert using single insert and you're sending an email every time you're doing an insert, then you will need to basically build some form of logic to not send so many notifications. So what we found is, if you have the time, it's probably better to build it the other way around. From the ground up, you start building your operation as a multi-delete or multi-edit or multi-create, and basically use it to insert one single data or delete one single resource. It's more complex, but on the long term, especially if it's your killer feature or like the most used feature by your users, you will save yourself some trouble. Some other dubious recipes I would like to share in part 3. Some problems that were reported by the CakeDC Corporation when they looked at our code is the problem that I think a lot of CakePHP applications have, is the problem of fat bottom controllers. So when you have some logics that you know that is not fitting in one table, because basically you have like a bunch of tables that are interacting and you don't want one model to start controlling other models, then you end up putting all the logic into your controller. And then it means that you cannot call this operation, for an example, from the CLI. And so you start doing like weird things, and your tests are slower. So ultimately, what we are doing now is we try to have one feature, one plugin. We use middleware to factorize common request and response logic. We use controllers to manipulate endpoint-specific request parameters, like the user input. For example, if we want to manage version 1, version 2, version 3 of different form of data input we support for the same logic, then we'll put that in the controller, or services that are called by this controller, and then basically handle the final response as well. So, and then we build services to perform the business logic that are agnostic of the request, ideally, and so that they use a well-defined interface, and you're not just passing like, okay, a data object that can have everything in it, but you have like a precise object that you're passing to this service, so you can better control the input and output. And we use models only to handle data access, so creation, deletion, validation, that sort of things. And if possible, we use dependency injection when you have business logic that is shared, but with some variation. So to give you an example, in the past, what we used to do when having like functionalities that digress a little bit between the cloud and other versions of Passbolt is to have this ugly if inside the logic. So we do have, for example, in the cloud, different some extra logics that we do before or after the common logic. Typically, for example, on the cloud, we have different OpenPGP backend, so that is optimized for speed and safety. And on the community edition, because you're running only a single instance of Passbolt, you don't have the same constraint. Then basically we need to be able to add that extra logic into the common logic. And so what we were doing before is this ugly if conditions directly in the code. You will say, okay, well, it's not that ugly. The issue it comes when you're having different code base and you need to merge this code, and you start having code that basically are on different branches, and some code will have just the common logic, and some code will have if is cloud, then do this extra logic. So every time you change that file, then you'll have a merge conflict. And so you end up having with a lot of opportunities for making mistakes during this merge. And what we started to do now is basically build some dedicated services. So common services and some services that are based on these common services and that are extended and injected using dependency injection. So it's very clean. The code is well separated. We still have some common code that we can maintain and test separately. Another common mistake that you will find in Passbolt code is the way we remap exceptions. So when you remap exceptions like it is on the screen, you're losing information about the context. You're not seeing what is the true origin of the exception you're throwing. So in some cases, it's okay. But in some cases, like for example, when you're dealing with OpenPGP, you may want to have some extra information about why it is failing at that time, because it's very finicky with, and it depends, for example, on some problems with your environment. So the real idea, the better way to do it would be to actually include that exception, the original exception, in the new exception that you're throwing to make sure that you give yourself a chance to debug that problem. Another mistake that we did and that Juan helped us fix is using one big data set for the fixtures. So instead of having maybe like one fixture per test scenario, we had like one big fixture for each of the tables that were linked together, and so that we had all sorts of scenarios already available for ourselves during the test. So typically we have a huge data set that have everything in it, like one active user, one admin, one deleted resource, one deleted user, all sorts of permission with groups and all that. The problem when you do this, ultimately when you start, it's very useful, but as you go, it becomes impossible to know why the test data was designed in such a way, because you kept adding to it, and you start, it becomes very hard to start changing that data set. So the better way to do it now is to use Fixture Factory, and for each of your tests, you basically create the data that you need to test, that you need for your test, and it becomes more maintainable. However, I have seen also some common pitfall for such approach. For example, when you start using like a user factory and you start creating generic GPG keys, then you're maybe in this factory you're not performing any build rules or validation, and you start basically having data that is not consistent with what you should have in the first place in your database when you're testing these scenarios. For example, here we are creating 3 users and they all have the same GPG keys, and it's fine. It will go ahead because it doesn't have the build rules complaining. However, depending on what you are testing, this basically might not be the correct data for your test, and so then becomes quite complicated to change also over time, because maybe you would want to change that behavior, and with GPG keys will start meaning something else, and basically it will affect all the tests that are using this particular approach. So you're back to square one with one big data set that is used in many tests that are not correlated. So yeah. Another big mistake we did initially, which led us to despair, is testing everything with Selenium. Selenium is great. It's the closest you can get to having somebody click on the interface And for us, it's very useful because, for example, when we have the browser extension, it's the only way we can test a browser extension with a particular version of the backend. But they are quite brittle, and they can require a lot of time for your infrastructure to help the developers, for example, upgrade version of the browsers or upgrade versions of the web drivers. And so it can become are using them extensively, and with every single error message scenarios. At the beginning, we were basically writing our user stories, and every single user story will be a Selenium test. It was very thorough, but it made the whole test suite brittle. So what we started shifting the strategy, and we started defining when a test should be in Selenium or not by looking at the value it creates for us or for our users. Is it something that is the most important part of your software, or is it maybe like some very small feature that a few people will be using? And so you can start moving things a little bit around and focusing on the happy path, or more like the core business, and move more test to unit test or fake integration test. So yeah, that's one lesson learned from us is it's not easy to define where the test should be at which layer, and what will be the reward for this particular test distribution. You will need to do some trial and error and see what works best for you. Another mistakes that we've done in the past is relying too much on plugins. I'm sorry, I don't mean to offend anybody working on the community plugins. They are great, like we love them and we love libraries, but they need to be considered when you implement them in your project as an investment. So you always need to look at what they do and reading the code, and see if they match what you're trying to do. For example, what I've seen is you will start using libraries or plugins that support an extensive set of functionalities, and you only need like a small subset. For example, you plug in a HOHOT library that supports like HOHOT v1 or multiple HOHOT 2 schemes, and you're only using like the most simple scheme in HOHOT 2, which basically can be like written in 3 lines of code. So sometimes you actually need to dig deeper into, is this library secure? Is this library doing just the bare minimum that I need? And our preference, because of the security impact, is not to actually look at how people are doing it and then basically doing it ourselves and just taking the good parts, if you will. Obviously, we still use some plugins, and if we can help, especially even for plugins that we don't use but that the community relies on heavily, we are happy to continue working with you guys and help sponsor some audits, for example, of plugins, or basically feel free to get in touch with us if we can help you with plugins or libraries. We'll be more than happy to pitch in and do our parts. So the third part of my presentation is about wild goose chase. So it's not technical problems, it's more like general problem or strategic problems. So one of the biggest problem which mistake that we did at Passbolt is historically or my friend and co-founder Kevin, when he started thinking about working on Passbolt, he actually did a version of Passbolt which nobody have seen, and it was what we call the version 0, and it was written in jQuery. It was very not pretty looking, but it worked, and people were already using it in some custom with some of our clients at the time. And when we started working on with more people on Passbolt, we agreed that we wanted to redesign it completely and make it more secure and basically have more features. And we started making grand plans. And we worked on it. We did like a rough estimation of how much time it would take to build that ideal Passbolt version. And we basically estimated it would take us 6 months. And we were right, actually. It took us 6 months and 3 years. And so we ended up with something that was not working at all. And that what was pretty much a disaster. And so at that time, we were like, okay, we can't continue like this. And what we did is we took everything that was working and removed everything that was not working. And that became Passbolt version 1. And so ultimately, this experience taught me a big lesson is to be very humble when it comes to building something. And especially if somebody has built something before, there's much to learn about that thing. Before coming and like proposing your ideas, you should always look at how it's been done and why, and try to fix things instead of like starting from scratch. Sometimes some things cannot be fixed, and it happens, and it's okay. But most of the time, I think when you become older as a developer, you find out that fixing is the fastest and the safest way to go. So another mistake, I think, that is there for Passbolt as an organization and for the general security industry in general is we are not explaining security well enough to our users. And so there is a lot of cheating going on in the security industry, where basically some companies rely on that to sell their products. They actually benefit from people not being interested in the topic or not having the time to dig into it or not having the skills. So they will basically come up with words that the stakeholders will look for when they purchase a solution and not look into the detail. And so this is one of the mistakes that we do at Passbolt. We are maybe like a little bit too technical and not like being able to explain in very simple terms what it means. We try to be as transparent as possible. We try to explain what are our limits, and but not everyone is doing this in this industry. So yeah, this is, I think, a collective mistake. One of the biggest mistake I think you can do as a project or as an organization is about learned helplessness. I'm not sure if you're familiar with this concept, but learned helplessness is a state that occurs when people experience a stressful situation in a repeated fashion, and then they become helpless because when they see that situation happening and they don't feel that they are able to control or change it, they stop even trying. At the beginning, they may complain, they may start to do something about it, but it doesn't work out. And so basically they learn that helplessness, and it generally is very detrimental to your mental health, to your well-being in general. And so I think it is one of the things you should watch for in your projects and your organization, is to make sure that you are not helping or promoting this helplessness and enabling people that are trying to fix it. So there are many things that you can do to fix helplessness. Is as our friend Clippy is saying here, is trying to help people identify negative thoughts and behaviors. So when you see someone being helpless and being like, I don't know, like cranky or angry about it, but they don't know to express it, they don't know how to put words into it, they don't know where to start to fix the problem, like sitting with them and saying like, okay, you're in this situation, you know, and helping them reflect a little bit on what's happening to them. So encouraging people that are trying to fix the problem, giving them support, even if you cannot fix the problem, the two of you, maybe, you know, you can try to grab more people to try to start tackling this problem. And as I mentioned previously, like good enough is better than nothing. You know, you should, even if you cannot fix the whole problem, maybe you can fix a portion of the problem, and somebody else can basically take it to the next level. One thing that is very important also is prioritizing your health. So if fixing the problem is basically detrimental to your health, then you should put your health first. At the end, you should not give up easily. That's one of the things that I've learned from my friends at Passbolt, is to continue and try to progress. So it's what we're trying to do also by being like today a little bit showing you our weaknesses and our mistakes so that you can learn from them. Thank you.